Experiment 2, linear motion. The objective of this experiment is to use linear attract to investigate Newton's second law of motion.
For the procedure, first, the linear attract was assembled as shown in figure 4.1. Next, the pump was switched on and let the air blow through the track for several minutes. The track was balanced by adjusting the screw on the leg of the track. After that, the one hook was inserted at one and a flag on top of the glider. Next, the mass of the length of the flag was measured and recorded. Then, the one of the string was attached to the hanger and the other end to the glider. Next, the masses with a mass of 20 grams was placed on the hanger and put the string over the pulley. After that, the glider exactly positioned before the photo gate. The glider was released and the time was recorded shown on the photo gate. Next, 2 times was repeated to obtain the time average value. Last, the procedure was repeated 4 times with 20 grams each added to hanger.
This is the result of linear motion experiment. The length of the flag was 0.10 meter and the mass of hanger is 0.01025 kg. We use different slotted masses on hanger starting 0.20 kg to 1 kg. We can calculate that the weight of force will increases and the acceleration also increase.
Linear motion is a one-directional motion along a straight line. The linear motion can be divided into two, which is uniform linear motion with constant velocity and non-uniform linear motion with variable velocity. This experiment focuses on Newton's second law, which is one of the most important in all of physics. The second law states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction of the net force and inversely proportional to the mass of the object. Newton's second law can be defined as force is equals to mass times acceleration, where force and acceleration are both vector quantities. If a body has a net force acting on it, it is accelerated in accordance with the equation and vice versa. The data obtained from this experiment supports the theory. The data shows that the force increases as the mass of the object and the acceleration increases. Other than that, there are a few errors that can be avoided in this experiment. For instance, the data that was obtained was not as accurate due to the parallax error because of observing the object at a certain angle.
The conclusion of this experiment is the relationship between total forces on object with the acceleration of object is direct. A net force on an object changes its motion. The greater the total net force, the greater the acceleration.
According to Newton's second law, the acceleration is inversely proportional to the object's mass and to the strength of the net force. Newton's second law explains how objects behave when subjected to unbalanced forces. The object accelerates as a result of the imbalanced forces with an acceleration that is inversely proportional to the mass and directly proportional to the net force.